Today we're going to talk about chemical reactions. You can either use your note cards, like so, or you can use your pink foldable. So the first thing we want to do is fold and cut our foldable. So we're going to fold it in half, like a hamburger, okay, with our words on the outside. Then we're going to take one of our sides and we're going to fold into that fold that we just created. Now we have made these foldables before, so they will look familiar. And we're going to do that to both sides of our foldable. Okay, next up we're going to take our scissors and we're going to cut on each of the black lines. So you should have a total of 8 doors. Okay, I'm going to do it on that side and then also on this side. Okay, then don't forget to flip to the back and put your name on it. Now that we have our foldable all made, we're going to flip to the back side where it says reactant and product and gives us different chemical reactions to balance. Okay, and we're going to go through our notes today on that foldable or your note cards. It just depends on what you're going to do. Now the first term we want to go through is that our chemical equations are going to show us that there is a chemical change occurring. Our equation just lets us know what's going on, like H2O yields H2 and O2. It lets us know what's happening with our equation. Now you'll notice that our elements are represented by their symbols, and the 2's for this problem and the 1 are our subscripts. Now the reactants, and you guys should circle them too and label, is going to be on this side. Now our reactants is the substance that undergoes the chemical reaction. You can also write that your reactants are always going to be on the left side. Now you may also want to label this right here as reactant, and your reactant is what you're going to start with. Because it's always on that side, it's what we're going to start with. Now our product is going to be on the opposite side. So your arrow actually represents yields, and our products are going to be located on the right side. And that's going to be what you end with. So we're going to write right here and end with. Pardon my poor handwriting. I hope you guys can still read it on the video. In this reaction, you'll see that we only have one reactant yielding 2 products. Now that's not the case each time. You can have multiple reactants and you can have multiple products. Now there's an easy 3-step process to balancing chemical equations. Step 1, first off, you have to figure out what you have on both sides. So what I like to do is once I read my example, I'm going to locate my arrow and then I'm going to draw a line down. This line is going to separate my left side, my reactants, from my products on this side. Now I'm going to label how many I have of each one. Now to decide how many you have, you're going to look back at your subscripts. Okay, how many H's do I have? Good, I'm going to have 2 H's. How many O's am I going to have? Excellent, 1. Now we want to put the same order I have on this side, so we're going to have our H and our O. So how many H's do I have? Good, 2. And how many O's am I going to have? Also 2. Now we'll notice, are both sides equal? How do you tell? Well, H has 2 on the reactant side and H has 2 on the product side. So that's equal, but O on the reactant side only has 1. O on the product side has 2, so we are currently not balanced. So we're going to have to balance this chemical formula. Okay, right underneath that chemical equation on your foldable, you're going to see a coefficient. Now our coefficient is going to go in front of the compound you have. Okay, so that's key. It has to go in front. It's not going to go in the middle. It's not going to go on the side. It's always going to be located on the front. Now this too is a coefficient for NaOH. What that coefficient represents is that it applies to the entire molecule. So that means how many NAs would I have? Good, 2. How many O's would I have? 2 also. And how many H's would I have? Great, 2 also. So that coefficient is going to represent for the entire molecule. Don't forget, it can only go in the front of your molecule. Also, remember subscripts like CO2 only apply to the particular element or the polyatomic ion, not the whole molecule. So don't forget, this 2 only represents for the O, not for the C. But let's say we add a coefficient of 3 in front of CO2. Well, we're going to distribute our 3 to our C and our 3 to our 2. So how many C's will I have? I'll still have 3, and how many O's would I now have with a 3 coefficient? Well, 3 times 2 is 6. Perfect. Now that we know where coefficients go, we're going to come back to our balancing problem. So step 3 is to add coefficients to the front until both sides are equal for the element. So if we go back to what we already had, we have H as being 2, O being 1, H as being 2, O being 2. Now what we have to do when we put coefficients is that we have to ask ourselves, what can we multiply? So notice that these coefficients we're going to be multiplying, not adding, subtracting, or dividing. So think of a number right now. What could you multiply 1 by to make it look like a 2? Excellent, a 2. So we're going to put a 2 on top, and then that distributes to the whole molecule of water. So we have to change H to 4 and O to 2. Now, our O's are happy. They're balanced. But what did I do to my H's? I've now changed my H's. So I need to make a 2 look like a 4. So what could I multiply 2 by to get to 4? Another 2. So I'm going to change it in my chart. Now I have 4 and 4. Check it off. They're equal. Now what could I put as a coefficient for O2? I can put a 1 here. You don't have to put 1s, but you'll see on testing quizzes, sometimes they'll just have the coefficients as a 2 to 1 relationship. Last but not least, always double check by adding up how many elements you have on both sides. If there are 2 of the same ones, then you have to add up those, not as 2 separate identities. The key to balancing chemical equations is to take your time and don't get frustrated. Trial and error is your friend, and follow those 3 easy steps to balance chemical equations. So how about we try a couple more together. Now you can put these on a separate sheet of paper after the first one, or you could add it on to those additional note cards. Now this one's also on your foldable and also in your note cards. So the same way that we did before, we're going to find our yield symbol, which is the arrow. We're going to draw a line down and then label how many reactants we have and how much. So how many ZNs do we have? We'll have 1. How many H's? We'll have 1. How many Cl's? We'll have 1. We're going to put it in the same order that we did on this side. So we're going to have 1 ZN, 2 H's, and 2 Cl's. Okay, now ZN is fine. There's a 1-1 relationship, but H and Cl on our reactant side has 1 and 1, and HCl on our product side has 2 and 2. So what could I multiply 1 by to make it look like a 2? So I'm going to put a 2 up here. Remember, if you put a coefficient to the front, you have to change it for all of them. So I'm going to change it for my H and my Cl. And then we're going to be balanced. We can put placeholders in each one, but you don't have to. Okay, our next one. We're going to have Al plus Cl2 yields AlCl3. Now don't forget, Cl2 is a part of Brinkelhoff, so it only exists in the form of 2. So how many Als do I have? I have 1. How many Cl's do I have? 2. How many Als on the product side? 1. And how many Cl's? Now this one's tricky. We can multiply things to get 2 to look like 3, but we're actually going to look for a common factor between 2 and 3. Good, 6 is a common factor. So what could we multiply 2 by to get to 6? So we're going to put a 3 up here. 3 times 2 is going to be 6. And what can we multiply 3 by to get to 6? Good, a 2. Now 2 is also going to change aluminum, but chlorine too. So now chlorine's fine at 6, but now this aluminum has 1, this has 2. So what can we multiply 1 by to get 2? A 2. So we're going to put a 2 right there. Double check that you're balanced. So we have 2Al, 2Al, 3 times 2, 6 Cl's, 2 times 3, 6 Cl's. Okay, last but not least, and then you guys are going to work on your own with a partner or by yourself on the in-class worksheet. So, Al, how many? 1. Fe is going to be 2. O is going to be 3. So we're going to do the same on this side. Al is going to be 2. Fe is going to be 1, O is going to be 3. So we'll notice that our O's are already balanced, but our Fe and our Al are not. So what could I multiply Al 1 to look like Al 2? So we're going to place a 2 here. So now Al and O are good. And what could we place in front of an Fe? Okay, we could place another 2. So now 2 is there as well. So let's count it up. 2 Al's, 2 Al's, 2 Fe's, 2 Fe's, 3 O's, and 3 O's. And we are all balanced.